Hello, everyone. So my name is Mu Zhang. I'm a assistant professor from the University of Utah. So today I will be presenting our work, right? So HPCSafeChain, right? So this project is focusing on the software supply chain security in HPC, right? So the project is motivated by our observations that scientific computing heavily relies on open source software packages, which, however, are vulnerable to software supply chain or SSC security attacks or vulnerabilities. Although there's existing research on SSC security solutions, but its applicability to HPC is still unclear, right? So especially the ways the software packages are being used in HPC bring new challenges, right? For example, C, C++ packages are heavily used in HPC, right, due to their better runtime performance, but their package management is very limited. Another example is AI machine learning packages, right? So they evolve very fast. And due to our firsthand experience, many HPC administrators actually allow users to download and maintain their own packages for flexibility. But of course, this will introduce new security risks. To address this, we propose three tasks, right? So first, we want to understand better the problem so as to build the attack taxonomy for HPC SSC security. And based on this new taxonomy, we'll further quantitatively measure the effectiveness of existing SSC security techniques in HPC. To do so, we'll develop a new HPC testbed and a attack benchmark, which are tailored for SSC security problems. So the result of this measurement will guide us to understand better, right? So which existing SSC security solutions are better suited for HPC. And we will also hope to understand what existing SSC security solutions techniques can be easily transitioned, can be easily enhanced to be transitioned to HPC. So our project introduces both innovation to cybersecurity as well as a new approach for transitioning the innovation. Specifically, we'll introduce a new attack taxonomy. We'll develop a new HPC testbed, attack benchmark for evaluating, validating, and transitioning SSC security techniques. So our transition leverages our collaboration with real-world HPC centers, such as the CHPC from Utah, HPCC from UC Riverside, and Idaho National Labs. So due to the nature of our research and the transition, so we actually require in-depth collaboration. So therefore, we will actually send a student to those HPC centers. The student will be co-advised by the HPC team as well as our faculty member. Right, so the student will actually serve as an insider, right? So for us, right, so they will gain administrator privilege, right, which is actually required for the software supply chain security research. So we believe our project can benefit a large group of people, right? So including HPC administrators, users, and also HPC and security researchers. So although there might be some potential risks, right, such as the completeness of our attack taxonomy, right, or the how to help the administrators, right, users, right, easily adopt existing SSC security solutions. But our mitigation strategy basically is to provide a more practical solution, right? So involving the prioritizing high-profile attacks and focusing on automated techniques that require less human efforts. So our evaluation and transition also leverages our collaboration with the HPC community and HPC experts. We seek to acquire their feedback on our taxonomy, testbed, and attack benchmark, and we will further use these artifacts to evaluate the applicability of SSC security solutions. So to sum it up, right? So this is a TCR project led by University of Utah and with UC Riverside, DeepBeats. We also have a collaboration with multiple HPC centers. So this is a 3-year project, and we will be starting in January 2026. So that's it.
Fantastic. So this is I'm really excited about this. I mean, I think this is a great example of TCR, right? Because you are directly engaged with those centers. I've via other channels I've heard from the the Idaho National Labs team that they're especially excited about some of this as well. So this is that's a great transition story. The attack benchmarks I think are something that can be pretty broadly used, but I think this is one where in terms of data directly dumped into an NDP or an OSDF, that's not quite the focus of the project. But I think there'll still be some good, the taxonomy will be a great thing to get out widely. Sounds like there's some data related to the benchmarks, but I wouldn't call this a sort of data set intensive project. Does that sound about right?
Yes, I agree. Yes. So we'll have some data, right? So especially this test bed, tech benchmark, right? We'll also need to collect the software packages, right, used in those real HPC centers, right? So their artifact source code, build scripts, right? So deployment tools, right? So all these artifacts, right? But I would say it's not a very data intensive project. That's right.
Sounds great. And this is a cool mix of stuff. So yeah, look, excited to kind of see this one going forward. And yeah, that's any other quick questions from anybody else? Otherwise, we'll move on to secure GPU for AI.
Yeah, I had a quick question. I was thinking of locally here at UW-Madison, all the different software I see flying about, and I would guess probably there's 20 to 30,000 different software packages in use across name your programming environment on the planet. I mean, just it's solving this generally is probably the equivalent to solving software supply chain in general. So,
Yeah.
how do you set your scope? How do you decide which people's containers you look at and which you don't, and how do you put boundaries to keep yourself sane?
Yeah, I think so previously I mentioned the challenge in addressing this problem in HPC, but actually solving this problem in HPC also provides us with some benefits, right? So we actually can focus on those software packages specifically or often used in this HPC domain, right? Which is comparing to this thousands of millions of packages, right? So using general computing environments, it's still a limited scope.
Oh, it may be challenging. Yeah, no, when I was saying 20 or 30,000 packages, I think that's on what you were calling HPC here. So there's extremely interesting diversity there. It'll be a lot of fun.
Yeah,
Mhm.
this is Manish. Sometimes you have to get on a Zoom call to figure out what your colleagues next door are doing. Uh, so yeah, I'd love to connect on this because I see from an indie perspective, I think the workspace aspect is a nice way to scale this out and we might explore that. So look forward to connecting with you, Mu, on that.
Thank you.